Hello dear students. In this session we are going to solve a numerical on double integration method. In this question we are given with a beam of length 6 meter simply spotted at its ends and carries 2-point loads 48 kN and 40 kN at a distance of 1 meter and 3 meter respectively from the left spot. We have to find the deflection under each load, maximum deflection, and the point at which maximum deflection occurs. The modulus of elasticity and moment of inertia is also given. So we have a beam. The length of the beam is 6 meters, simply supported, carries 2-point loads 48 kN and 40 kN. Distances are also given. These are the two distances from the left support. And we have to find out the deflection under each load. What is the deflection under 48 kN load and what is the deflection under 40 kN load? What is the maximum deflection in the beam? And the point, we have to find out the point at which maximum deflection takes place, right? E is given to us and a moment of inertia is given to us, right? So let us solve this problem. A simply supported beam like this, where there are 2-point loads 48 kN at a distance of 1 meter, 40 kN at a distance of 3 meter, and total length of the simply supported beam is 6 meter. Also the modulus of elasticity of the beam and moment of inertia is given. We have to find out the deflection under first load, that is y1, and deflection under second load, that is y2, and the maximum deflection. These things we have to find out, and we want to use the double integration method to solve this question, right? In double integration method, we know the deflection equation. Main deflection equation is ei d2y by dx square equal to minus m at a distance x. So this is the main equation. We have to use this equation and we have to integrate twice to get the final result, the deflection under each load and the maximum deflection, right? So how should we proceed? First we have to take the section x at between A and C, then between C and D, and then between D and B. 3 times we have to take the section x, right? Although we will combine these things, but before that we want RA and RB. What is reaction at A and B? Because it will be used, because when we find out moment, the moment of RA will be required if you are taking left side, right? So how to find out RA and RB? So to find RA and RB, let us solve this question. Solution. First we want to find out RA and RB. Take moment of all the forces about RA, right? And the body is in static equilibrium, so moment about A will be equal to 0. So take moment about A. Moment about A. What is moment about A? Sum of all the moments about A. The moment of RA about A will be equal to 0. Moment of 48 about A will be 1 meter. Let us take clockwise as positive. So this is 48 multiplied by 1. Again, moment of 40 about RA about A, that is 40 multiplied by 3. So this will be clockwise again, 40 multiplied by 3. And moment of RB about A, so that is RB multiplied by 6, and it is anti-clockwise, so this is minus RB multiplied by 6, right? Distances are taken in meters, right? From here, and these movements should be equal to 0 because moment about A should be equal to 0. So we can get RB from here. What is the value of RB, right? Solve it and you will get the value of RB, and it will come out to be 28 kilonewton. 28 kilonewton. So this is the one of the reaction, that is RB, and that is 28 kilonewton. So RB come out to be 28 kilonewton. Now we want to find out RA. To find out RA, we can take the vertical forces. Sum of all the vertical forces should be equal to 0 because body in static equilibrium. So downward forces should be equal to upward forces. We are assuming RA is also in upward direction. So sum of all vertical forces should be equal to 0. So what are the downward vertical forces? These are 48 plus 40, and that should be equal to RA plus RB. RA plus RB. RB is 28. So from here we can find out RA, the reaction at point A, RA, and that will come out to be 60 kilonewton. So RA come out to be 60 kilonewton. So we have obtained both RA and RB now, right? RA and RB is known to us. Now we have to use this equation, deflection equation, and here we need bending moment about at a distance x from the one of the supports, let us say A. So we have to do this activity 3 times. We have to take the section between A and C, then between C and D, and then between D and B, because the loads are changing here. One of the section will be valid between A and C, another will be valid from C to D, and another will be valid from D to B. But we can combine by the dotted lines, like we have done in our theory lectures, that we can take only one section. Okay, only one section can be taken like this at a distance x, like this. We have taken only one section x, right? Now if we are taking only one section at a distance x at the end between D and B, last section of the beam, now when we are taking the moment of RA, it will be valid between A to C. When we are taking the moment of RA and 48, it will be valid between C to D. And when we are taking the moment of all 3 forces, it will be valid between D to B, right? So if we find out Mx now, that will be equal to 60 multiplied by x. 60 multiplied by x. It seems that is as if this x is taken between A and C. So if it is taken between A and C, this is 60x. So this is 60s, which is valid between A and C, right? I am taking a dotted line here, right? It shows that this is valid between A and C, first part of the beam. Then between C and D, we have taken a section. If we are taking section between C and D, then the moment of this and this, so RA, this will be 60x, which is already written. Moment of 48 will be equal to, assuming that the section is taken between C and D, right? So let us do activity like this, that we are taking the section, right? So that there is no confusion. This is 48 kilonewton and this is 40 kilonewton. We are doing this activity so that there is no confusion to the students, right? First section is taken here. Suppose x is taken here like this, and we have x is taken here, and we are taking the moment of this is 60x, which is valid between A and C, right? So this part is valid between A to C, right? Is it okay? Right. Now next part is let us take the section here. Although we have already done in theory lectures, still we are doing it like this, right? Now moment of this is 60x, which is already written, multiplied by moment of 48 about this axis, right? Moment of 48 will be equal to x minus 1. This will be the moment of 48. So this will be minus because it is negative bending moment. So this is 48 multiplied by x minus 1, right? And this will be, and again this will be valid, this whole will be valid now, 60x, moment of this and moment of this will be valid between C to D, right? We will use it for C to D, right? So one part is valid between A to C, another part is valid between C to D, whole part 60x plus this thing, right? And third part, take the moment about this axis between D to B, and moment of RA 48 and 40. So moment of RA will be 60x, moment of 48 will be this, and then moment of this will be equal to, that is 40 minus 3, x minus 3. So this will be minus 40 multiplied by x minus 3, right? This is the third part, right? And this entire when we use will be valid between D to B, right? So that we have combined this right into single bending moment. So when we will be between A to C, then we will use this part only. When we will be between C to D, we will use both the part up to second dotted line. And when we will be between D to B, then we will use whole bending moment, right? So this is the concept, right? Now use this equation. We know the bending equation is EI d2y by dx square will be equal to, this is double integration method, right? So we have to integrate it twice, that is equal to minus of this thing, so minus 60x dotted plus 48 x minus 1 dotted plus 40 x minus 3, right? This is between A to C, then C to D, and then D to B, right? Integrate it once, we will get the slope. So by integrating, we are getting EI will be EY dy by dx. The integration of d2y by dx square will be slope dy by dx, and that will be equal to integration of this. This is minus 60 x square by 2 minus 60 x square by 2 plus we will get a constant, right? We are putting constant here because it will be valid for entire section. So for if we use it later on, then we will not be able to use here, but the constant is valid for this, for this also. That's why we are using in advance in the first section, right? Plus integration of this, that is 48 x minus 1 whole square by 2 plus integration of this, that is 40 x minus 3 whole square by 2. So this is how we have done, we have find out the slope, right? So what is the value of slope now? The slope is, we can write slope here is EI dy by dx will be equal to, this is minus 30 x square plus c1 is unknown to us, we have to solve this, plus 24 x minus 1 whole square dotted plus 20 x minus 3 whole square, right? So this is our slope equation. It will be required if we have to find out the slope. This will be required, right? Now integrating it, we will get the deflection. So integrate it to get the deflection, right? So find out the deflection now. For deflection, what we can do is we can further integrate it to get the deflection. So integrate this equation. So EI and dy by dx integration will be y. Integration of dy by dx will be y. So EI y. So EI y will be equal to integration of this minus 30. Now it will become x cube by 3 minus 30 x cube by 3 plus integration of c1x, and we will get another constant c2, and then we are using the dotted line valid for A to C. Then integration of this 24 x minus 1 cube by 3, and then integration of this x minus 3 cube by 3. So this is the integration of this slope, right? And we will get the deflection now. So what is deflection now? EI y will be equal to, this is minus 10 x cube plus c1, and the integration of this is c1x plus c2 plus 8 x minus 1 cube plus 20 by 3 x minus 3 cube. So this is our deflection equation. obtained by integrating twice. That's why it is called double integration method or Macaulay's method, right? So this is our equation. Now we have to find out the C1 and C2 boundary conditions will be applied, and to find out the C1 and C2. So what is the value of C1 and what is the value of C2? How to find out the values of C1 and C2? Boundary condition. What are boundary condition? We know that at simply sports, the boundary condition is given by that at sports there is no deflection at A point and at B point there is no deflection, right? So boundary conditions are at x equal to 0, y is equal to 0, and at x is equal to total length, which is 6 meter, y is again 0, right? These are the boundary conditions. So these boundary condition will be applied. So let us use first boundary condition, this boundary condition. At x is equal to 0, y is equal to 0, we want to utilize this equation. This equation is between point A and C, because we are applying the equation at this point, A point, and this is applicable between A and C, right? And for A and C, this part is there, 60x part, which is integrated to get this part, right? So now for this part we have to use only this part, right? This part only, right? So put here x equal to 0 and y equal to 0 in this equation, deflection equation. We will get 0 equal to minus 10 0 cube plus C1 multiplied by 0 plus C2. From here we will get C2 equal to 0. So one of the constant is obtained to us, that C2 equal to 0, right? Now second boundary condition is this: at x is equal to 6 meters, y is again 0, because at suppose the deflection is 0. So but this part lies between D to B, so whole equation will be valid. We have to utilize this whole equation to get the value of deflection at B point 0, right? So that we can find out C1. So put x equal to 6 meter at and y is equal to 0. Y is equal to 0 at x is equal to 6 meter. Put here and use entire equation. So EI 0, so this is 0, that will be equal to minus 10 x cube. X cube is 6 meters, means 6 cube, plus C1x. C1 is unknown to us, which we have to find out. C2 is already 0, we have already obtained. C2 is 0, this, plus 8 times 6 minus 1 cube plus 20 by 3, 6 minus 3 cube. Entire equation will be used because this is between part D and B, right? This because we have to find out at B, deflection at B, right? So from here now only one unknown is there, that is C1, and C1 can be obtained. So what is the value of C1 now? So C1 will come out to be, solving it you will get the C1 as 163.33. This is the value of C1. So now we are able to find out the value of C1 and C2 both. Now this deflection is known to us, that EI y will be equal to minus 10 x cube plus C1 is known to us 163.33 x, C2 is 0, plus, and this is the deflection when we are using A to C, right, which is valid between A to C, plus 8 times x minus 1 cube plus 20 by 3 x minus 3 cube. So this is the deflection equation, right? Now if we want to find out the deflection, then this is valid between A and C. If we want to find out the deflection under 48 kilonewton, this is between A and C. So you can use the equation which is valid between A to C. This is the first equation, first dotted line. Also it is the C point lies between C to D, so both are applicable. But you will see that when we apply 1 meter, this will become 0.
and it is not required. This is not required because this is between D to B. So only A to C part is required, right? So if we want to find out finding deflection y1 to find out deflection y1, we will use the equation for A to C, first part only, A to C only, right? It is required. Means EI y1 which we have to find out, EI y1 which we have to find out will be equal to minus 10, and the x value is, the value of x at this point is 1 meter, right? For y1 the x value is 1 meter. So this is 1 cube plus 163.33 multiplied by 1, right? And finding out y1 we have to divide by E and I, right? E and I are also there. So I am directly writing here y1 divided by EI, right? So this is divided by EI. What is the value of E and what is the value of I? E and I is given to us 2 multiplied 10 to power 5 Newton millimeter square. Now if we want the answer in millimeter, then what we can do is, we have used this 48 in kilonewton, and we have to remember that this is used in kilonewton, and if you want the answer in millimeter, then what we can do is we can multiply it by 1000 to replace this kilonewton, kilo, and then this is in meter, this can also be multiplied in 1000 so that it may become in millimeter, right? So that answer may come in millimeter, or otherwise you can use this 2 into 10 power 5 in Newton meter square, so that answer may come in meter, right? So 2 into 10 power 5 Newton per millimeter square is there, so you can multiply it by 10 power minus 6, so that answer may come in meters, right? Multiplied by I, this is E, and multiplied by moment of inertia I, because the EI was there, right? This EI is there, which came into denominator. So I is 85 multiplied by 10 power 6. 85 multiplied by 10 power 6 millimeter to the power 4. So it will become 10 to the power minus 12, right? This much, but here this is given in kilonewton. The load was used in kilonewton, so that kilo should be replaced with 1000 to get the answer in SI unit. That's why I am multiplying it here by 10 power 3. The answer will come now in meters, right? Whatever answer will come in meters, and if you multiply it again 10 power 3, 1000, the answer will come in millimeter. So now the answer will come in millimeter, right? So you will get the answer as y1, the deflection under this load, as y1 equal to nearly approximately 9 millimeter. So this is first answer, 9 millimeter, right? Solve it and you will get this answer, right? 9 millimeter, right? Now we have to find out the deflection under y2 also, under D point y2, right? So deflection y2 we have to find out now, and it will be valid between C to D, right? So the equation which is valid between C to D, this equation, second dotted line, up to second dotted line between C to D, right? And in this case x is 3 meters, the value of x is 3 meters, right? So from here we can find out the deflection. So y2 will be equal to this equation divided by EI up to this part, second dotted line, because C to D is there, right? So minus 10 multiplied by x cube, we are taking in meters, so this is 3 to the power cube, plus 163.33 multiplied by x, this is 3, plus 8 times x minus 1, which is 3 minus 1 cube, and this is not required because this is value between C to D, and this part is for D to B, divided by EI, divided by this EI will be in denominator, that is 2 multiplied by 10 power 5 Newton per millimeter square multiplied by 10 power minus 6, so that it will become not 10 power minus 6, this is 10 power 6, 10 power 6 because it is per millimeter scale, no? 10 power 6 multiplied by 85 moment of inertia in meter की power 4. This is meter to the power 4, this is Newton per meter scale, and this equation is now, the force is in kilonewton, so it will be multiplied by 1000 so that it will become Newton, and again 1000 so that the answer may come in meters, right? So y2 will come in now millimeters, the answer will come in now millimeters, right, when we multiply by 1000. So answer will come in millimeters, and what is the answer? The deflection under 16.7 millimeter, 16.7 millimeter, this is the another answer, right? So we have achieved two answers: deflection under first load, deflection under second load, deflection under 48 kilonewton load, deflection under 40 kilonewton load. Now we have to find out the maximum deflection, getting the maximum deflection, y max. Now to get the y max, we know the slope equation. What was the slope equation? What was our slope equation? We know that at maximum deflection the slope is 0. The slope is 0 at maximum deflection. The slope dy by dx is 0 when the deflection is maximum. So we have to differentiate this equation, y equation, and then we have to put the slope equal to 0, or we already know this in the differentiation of this slope is 0, and we know that most probably the maximum deflection between C to D, because the loads are there, so maximum deflection probability is between C to D only, right? So we are assuming that this is the part at certain E point there is maximum deflection, right? This is our maximum deflection, y max, right? So if it is y max, then it is valid between C to D, and the slope at maximum deflection is 0. So this is our deflection equation. If it is differentiated, this part is not required, this part is not required because it is C to D, right? So if we differentiate this equation and get the slope, that slope may be equated to 0 to get the value of x at which the deflection will be maximum. So differentiate it again, or otherwise we know differential equation is there, ei dy by dx. This equation is already we have used when we were integrating the deflection equation. So differentiate it, ei dy by dx, the differentiation of this will be minus 30 x square, minus 30 x square plus 163.3 plus 163.33, and the differentiation of this, that is 24x minus 1 whole square plus 24x minus 1 whole square, right? So we have differentiated this equation, and to get the maximum slope, this should be equal to 0. This should be equal to 0, right? Is it okay? So now ei cannot be equal to 0, it means this part is equal to 0. So this is a quadratic equation which can be solved. So this is quadratic equation, that is minus 30 x square plus 24 x minus 1 whole square plus 163.33 equal to 0. So it is a quadratic equation which can be solved to get the value of x, right? I am writing directly the value of x. You can solve it using mathematics calculator and find out the value of x. This is a quadratic equation. So value of x, find out the value of x. It can be somewhat further solved so that it will be easy for you to solve it. So this is 6x square. I am writing somewhat more simplified form of this. 6x square plus 48x minus 187.33 minus 187.33 equal to 0. Now you solve it. It is very easy to solve this quadratic equation to get the value of x. The value of x will give that value where the deflection is maximum now, right? That value from A, taking from A, right? So x basically gives the value of AE, from starting from A to the E, AE value. So what is the value of x? So that will come out to be 2.87 meters. 2.87 meters. So this is the value of x, right? So it is slightly less than 3 between C and D at certain point E. So this is the maximum deflection, the point of maximum deflection. But what is the value of maximum deflection? What is the value of maximum deflection? Put this value into this equation to get the maximum deflection. This is not required because this is required when we are taking the point between D and B. But we are taking point C and D, so this part is okay up to second dotted line, right? So you can put here, so y max will be equal to putting here 2.87 value, so minus 10 multiplied by 2.87 cube plus 163.33 multiplied by 2.87 and plus 8, 2.87 minus 1 cube divided by EI. This EI will come in denominator, this value 2 multiplied by 10 to power 5 multiplied by 10 power 6 Newton per meter square. Moment of inertia 85 multiplied by 10 to power 6 multiplied by 10 power minus 12. Moment of inertia in meter to the power 4. This answer will come out to be in, and this should be multiplied with 1000 and 1000, so that it will become Newton SI unit, and the meter will become millimeter, so answer will come in millimeter. So this answer multiplied by 10 power 3 two times, right, to get the answer in millimeter. So y max will come out to be the maximum deflection 16.75 millimeter. So this is the last answer of this question, right? So we have obtained two deflections under two loads, deflection under 48 kilonewton, deflection under 40 kilonewton, and then the maximum deflection. For maximum deflection we have used that the slope at maximum deflection is 0. So we have differentiated this equation to get the slope. So we differentiated it and equated to 0 to get the value of x where there will be maximum deflection, and putting this value of x again in this equation, deflection equation, we can get the maximum deflection.